And now we have the single stage process. In the single stage process, our system are getting in contact, mixing them para magkaroon ng equilibrium. Tapos, the fusion and the distribution of components, since there is equilibrium, then after there is separation. The single stage equilibrium process. This represents the single stage equilibrium process since yung L0 and V2 are being contacted in a long time. L1 and V1 will be in equilibrium with each other, making an overall mass balance, material balance. We have L0 plus V2 equals L1 plus V1, and we will represent it as M. In the equation, L0 is the liquid entering the system, V2, the vapor entering the system, L1, vapor leaving the system, and V1, vapor entering the system. Having the component material balance, assuming components A, B, and C are present in the strips. For A, we have this equation. L0 times the mass, the mole fraction of A, plus V2 times the mole fraction of A equals L1 plus mole fraction of A plus V1 times the mole fraction of A. The M is the total flow of material in the system, the sum of the liquid flow and the vapor flow in the system. For C, ito naman yung equation. Then for B, hindi na natin kailangan magkaroon ng component balance since mayroong relationship yung mga mole fractions ng A, B, and C. That is equal to 1. For a single stage gas-liquid system, it is a system wherein a solute A in gas phase B along with inert air B and in liquid phase L along with inert C. We have A and B in the gas phase and C in the liquid phase. We have, assuming that air is essentially insoluble in the water phase. In the water phase, our gas phase is a binary AP. Since insoluble yung water phase, magkakaroon lang tayo ng binary AB, yun lang yung magiging system natin. And water does not vaporize into gas phase, so hindi magkakaroon ng P dun sa gas phase. So, ang magiging system lang natin is a binary AC. Having a component balance in A, in moles and in mole fraction, ito yung makuha natin equation. Note that L prime and V prime are constant and usually known. So, since given na yung L prime and V prime, makukuha natin yung relationship ng XA prime and Y prime in equilibrium yung Henry's law. Ang Henry's law, di ba nag-a-apply lang for them new solutions? Henry's law ay yung Y1 equals sa H prime XA1. Yung H prime ay yung Henry's law constant. Pero kapag hindi naman dilute yung solution natin, kailangan natin ng equilibrium data in the form of PA or YA versus XA.
In many chemical and other process industries, transfer of mass from one phase to another is usually accompanied by a separation of the mixture. That's why we are discussing all of this. So as a review, from the single stage, it's very expensive kung gagawin lang natin. So from the single equilibrium stage diagram. liquid and vapor phases natin are contacted with each other and then separated. We could do na yung B1 natin, yung product natin, could be conducted with fresh LO again. But then, it will be very expensive and the product L1 will be very diluted. So we could do this multiple stages, but then, it will be very expensive. So what we do is multiple countercurrent contact stages. So yung magiging flow diagram natin will look like this, where L naught and Bn plus L naught and B1 are our primary phases. Tapos, N is the total number of equilibrium stages. The purpose is to transfer more solid from one phase to the desired phase. Because as I have said earlier, if we do this multiple times by contacting B1 with fresh LO every time, L1 will be very diluted. An advantage is we conserve L0 and get the more concentrated product. And B and C might be musical with each other. We assume that all of our components A, B, and C are present in this flow process. Our component A is present and is contacted in our liquid and vapor streams. Then B is more present in our vapor stream and the component C is more present in our liquid stream. So our overall mole balance on all the stages will be L naught plus B sub n plus 1 is equal to L n plus B1 is equal to M, where M is equal to the flow. Considering the first n stages, yung from dun sa flow diagram natin, our overall balance will be L naught plus Bn plus 1 is equal to Ln plus B1. So our component balance where x and y will be our mole fractions, it will be L naught x sub naught plus Bn plus 1 y n sub naught y n plus 1 is equal to Ln x n plus B1 y sub 1. The overall component balance on all stages, A, B, or C will be that equation. So solving for yn plus 1, since most of our solution for our equations will be graphical, we will solve for an equation of the line. This is more detailed in our discussion in ChE 152. So we take yn plus 1 is equal to ln x of n equals over bn plus 1. So this is a simple mathematical manipulation of the equation earlier. So this is the operating line which relates the concentration yn plus 1 in B stream with the x of n in the liquid stream passing away. The special case for being serializable with each other and thus there's a transfer of solid A between the two streams. And to determine the number of ideal stages needed to bring about a given separation, the calculation is done graphically. So in the interest of time, because we will still be discussing the problem. So next, this is a discussion of the two types of calculations. So yung number of stages, procedure, an outline of the procedure, an equilibrium line is valid which relates the composition of the two streams in equilibrium with each other leaving a stage. So starting from stage 1, y1 and x sub naught are on the operating line and are plotted. So the vapor y sub 1 leaving the stage in equilibrium with the leaving x sub 1, then y sub 2 and x sub 1 are on the operating line, then y sub 2 will be at equilibrium with x sub 2 and so on. So stepping is done and then yn plus 1 is achieved. So we remember this from our detailed discussion in ChE 152. So yun yung paggawa, yung maki-implement method siya. Number of stages conjure. Yan, ito yung magiging itsura niya. So maalala pa naman natin siya from ChE 152. So yun yung analytical equations for multiple stage contact. So we assume na yung liquid and vapor streams natin are almost in equilibrium with each other. So when flow rates L and B are essentially constant, the operating line becomes straight and thus determination of ideal number of stages can be done using simplified analytical equations. So yung overall component balance ng A natin magiging ganito na. O parang yung kanina lang din yan. Tapos i-rearrange lang natin to get the next equation natin. Oo nga, yung subscript natin ay malalaki na lang. Overall component balance for the first n stages, so katulad lang din nung kanina, nagaganda lang yung mga subscripts natin. Pag in-equate natin siya, ito na siya. Tapos, since sinabi nga kanina yung molar flow rates natin para masimplify yung calculation, ay constant, L is equal to L sub n, and equal din siya sa L sub capital N. Tapos yung B, equal din siya dyan. Kaya yung magiging equation natin, mas magiging simplified version na siya. Tapos, isa pang simplification dun sa mga equations natin ay yan. Yung mole fractions ng sa n+1 stream natin ay equilibrium na with each other. Kaya, pwede na ma-relate yung sa equation natin earlier na equal na din sa m. Tapos, isa-substitute lang natin yung a, para ma-simplify yung calculation. Igagawin mo siya equal sa L over m. So, b yung magiging equation na natin ay magiging ito na. So, yan. So, next. Yan. A will now be called absorption factor. So, yun. Yun yung tatawag natin sa kanya. Equation is a first order linear differential equations. Maalala natin siya from NSI 21. Can be solved by calculus. Equations are derived are the following. So, for transfer of solid A from L to B, for unit stripping, ito yung case 1. So, para sa stripping. Tapos, yung case 2 naman ay kapag yung A natin ay equal sa 1, so mas magiging simplified pa siya. Yan. So, yung kanina, yung case 1 is for stripping. Itong case naman na to is for absorption. So, yan. Yan na yung equation natin. And yung note lang, A ulit ay absorption factor and S yung stripping factor naman siya. Equal sa inverse, so 1 over A. Yan. So, thank you for listening. Pero yun nga, para mas maintindihan natin siya, mas makikita natin siya kapag meron tayong sample problem.